Hey everybody, in this video we are going to practice transforming graphs, specifically the cosine graph or the cosine equation or cosine function, whatever phraseology you would like to use. So let's dive in. First and foremost, I suggest you watch the SINE video that corresponds to this first, because I'm not going to go into as much detail because the other video was 16 minutes and I would like to keep it a little bit shorter than that. All right. Let's start here. Input values. So for the input values, I'm still using the quadrantal angles as I did in the previous video. I did already have them filled out for us. Quadrantal angles are the angles that separate the quadrants. So that's what I'm going to look at to begin. Then the outputs are going to be the answers that we would get if we were to find the cosine of those input values. Then I will take those inputs and inputs and outputs and put them on my graph. So the outputs are your y values and your inputs are your x values, and I'm going to map them together. That's how ordered pairs work, right? We're going to find the mapping of them together, and we're going to make the shape of the cosine graph, and that's going to be your parent function. And then all we need to do is see how ABHK affects it and use that and apply it to another graph, and just go ahead and we'll graph something like this. So feel free to fast forward to whatever part you might need to focus on, but I'm just going to quickly go through it and try to keep this as fast as possible. Okay, so sorry, I just want like a good black marker. All right, what are my quadrantal angles for my inputs? Those are the angles that are going to separate the quadrants. So I have 0, I have pi over 2, pi, 3 pi over 2, and 2 pi. Those are going to correspond to these locations over here, as if I could cut my circle with a scissor and unravel it and use it for the axis. So I just filled that in as well. All right, scooch that over a bit. That's done. Now here, what is cosine? Cosine is the x coordinate on the unit circle. So x, y, if you don't know what the heck I'm talking about, go learn the unit circle. You're probably trying to learn this before you learn the unit circle, or I don't know, you never paid attention in class. X value in the unit circle, that would be 1, 0, -1, and 0. 0, obviously it matters where I put them. I mean, I'm making a graph, right? 0 is in the middle, 1 would be above it, and -1 would be below it. So now I'm going to correspond and draw like the mapping of one to the other and get it all together on a graph. So what's that going to look like? The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. So really, in reality, if you forget, do you need to do this? No, your brain needs to know that this is where the graph comes from. You are just graphing the results on an XY plane. I know we like to think the unit circle's on a plane, but it's like transposed on a plane. It's not the graph. We just use that as a graphic organizer to make it easier for us to figure out the values of sine and cosine, sort of like we would use that in the back of those black and white composition notebooks, the times table chart, where it goes like 1 through 15 and 1 through 15, and you can find what multiplies. That's a graphic organizer. You know, it's a way to organize it. Is that how you calculate? No. Is it a graph of anything? No, it's just a chart, like a flow chart, if you will, like same idea. Okay, back over here, sorry. The cosine of 3 pi over 2. So if you know what cosine is of the quadrantal angles, you could just sit and plot them, right? And then the cosine of 2 pi is 1. Now this wave is exactly the same wave as the sine wave. It's just shifted over a smidge, okay? 1/4 of a period, really. This is moved in the left direction, if you will. So here, between here and here, it's going to be concave up. I used the word concavity in other videos, so I hope you know what that means. Now this, I'm just going to dot. It's going to keep going. So if you draw this really pointy or pointing up at the end, I hate that. Here. So this really goes forever. Weave. There's your graph. The period is from here to here. That's one period. Then we have 4 quarters. Q. 4 quarters, like a football game, make a whole game, right? So we're breaking it up. Domain and range. The domain is going on and on in both directions forever, negative infinity to infinity, and the range from bottom to top, including 1 and negative 1, like that, because this wave just oscillates between those two values. So can I be more general? Because what if I have A, B, H, and K? Like, how do they play a role in the making of my graph? Well, I'm glad you asked. So if I had those values, my K, for example, is my vertical shift. It moves my graph up or down. That is going to play a role in where this midline or sinusoidal axis goes. So this is called fancy sinusoidal axis, not fancy midline. So the value of K goes there. If K is positive or negative, that's what goes in that box. Again, that is spelled out, sinusoidal axis. Really, all 6 trig functions are some form of sine. Like, really everything can be written using sine, but it's just easier to give it a new name when it's in these different positions. So cosine is really the positive and negative square root of 1 minus sine squared. I don't want to call it that, so they call it cosine because they are cofunctions, yada yada. Next, VA. VA determines that distance to go up and to go down. So since A plays a role in that, that's your vertical stretch. It took a wave that was 1 unit long. If A is 2, now that wave is 2 units tall and 2 units down. If A is a half, then it's a compression. Does it change anything here? No, it does not. So this over here, K plus A, really absolute value of A, K minus absolute value of A. A little small, sorry. Okay, there you go. What else do we have? K is really blue, I guess, so we can do that. We have that right there is your left and right. I don't know why I'm labeling it this time. That moves it left or right. That's your backward house. So H, the opposite sign. Like, you would set that inside equal to 0 to really find it, okay? Because it's like, oh, another way to think of it, maybe this will help some people, is if you go minus H, like, what do you need to do to calibrate it and recenter it? I keep using that word calibrate, but you would go with plus H. So it kind of whoop, gets you centered back over there because of the way it works inside of the function. Anywho, I'm just not trying to use the same colors every single time because I feel like it's better if I make everything look different. Now the period we said is 2 pi over b. Yeah, okay. That color's actually garbage. Yeah. This marker period is 2 pi over b. So then Q is 1/4 of the period. So Q is the distance in between all these. So to get all these, we do plus Q each step of the way. Plus Q, plus Q. Obviously, this is not very formal. This is super shorthand, plus Q to get all of those values. So how do you get Q? From P. But how do you get P? You need the B. So A is used and K is used vertically. H is used and B is used horizontally. And if you remember earlier, those rules still apply, right? Vertical A and K, horizontal B and H. Same rules, they still apply the exact same way. Anywho, it's a little harder to see with trig because I'm not graphing it on a proper grid because of the increments of pi. So I feel like it's hard for some people to see, but I need you to like really turn on your imagination, okay? There's domain and range. How does that apply to all of this goodness? Well, where'd that black marker go? The domain is still going to be negative infinity to infinity. And like the last one, the range bracket is from K minus absolute value A, comma, K plus absolute value of A. And there's your range. It's a little squashed, but there's your range. Okay? So let's do an example, shall we? We shall. Okay. Yikes, so bright. Sorry, it's just this time of day, the brightness in this room gets more or less, and sorry. That did not make it better. That made it worse again. I don't know. Can you see it? I think you could see it. I'll rewrite this equation a little bit bigger. Y equals, I'll even color code. How nice am I? The A is -3. Oh wait, I forgot to graph that other one. All right, but let's finish what I'm doing. Cosine.
Okay, bye. This week. Bye-bye.
Then we got +7. Plus 6 pi over 5 theta. And I guess for the B, I will use that green, but this one, the tip looks like a little smoshed. Five over 2. Yikes. Better, but what did I forget to do? I forgot to actually draw my cosine wave and to draw my little cosine mnemonic, not mnemonic device, maybe it's a mnemonic device. So if you have positive cosine, it's going to look like this right here. So concave down, concave up, concave up, concave down. Maybe you dramatic, make the points nice and clear. That's positive cosine versus negative cosine will be like that. Now, where's the little mnemonic device picture? If you look at it sideways, C-O-S-I-N-E. So it's like cosine. Can you see it? Maybe? Whatever, I tried. I'm trying to help you. Don't give me attitude. Shut up. Be nice. Okay, so here we are. All right, one last thing to try to fix. All right, doing my best, guys. Okay, from here. First thing I like to label, I don't know, I think it's always the K for some reason. Also, you could just draw it right away. Just make yourself the cute little grid. It's box-wise, it's like a 2x4 in the boxes. So say you draw this grid of 2x4, right? Like to get yourself going. Let me get a light gray marker. So say for yourself, you want to make a 2x4 grid. What you want to do is extend beyond just keeping it a perfect rectangle. Like you want these lines to stick out. You can't see that. You want them to stick out though, okay? Yes, that's better. So this, I'm just making a grid. So if you were doing this in your notebook, if you want 4 boxes, you need 5 lines. And if you want 2 boxes, you need 3 lines. Just gonna make this one really thin. But do you see how I like let the lines go past? So you want them to go past so you could label off of it. Otherwise it's like, ugh, too squished, okay? We don't want it too squished. So the +7 is right here. That is our sinusoidal axis or your midline. They're at 7. Next, if I add A is -3. That's why I use absolute value bars. So what's 7 plus 3? 10. And what's 7 minus 3? 4. While I'm here, I have a negative cosine graph here. That's what I'm working with, a negative cosine graph. So what can I do? I could draw it right away. That's the shape of a negative cosine graph. Now, does it keep going? Yes. If you drew yours sticking down, you're lying, okay? It's not going to go like that. Okay, it's going to look more like that forever, ever, and ever. All right, next, H plus 6 pi over 5 means it moved left. So this is H really equals negative 6 pi over 5. I'm going to wait because I might need to find a common denominator, so we shall wait and see. For domain and range, I can actually write them right now because the domain is always negative infinity to infinity with parenthesis, right? And the range is bracket from the lowest 4 to the highest 10. So that's done. Now I need to figure out the period and quarter period. Okay, there's B, 5 over 2. Period equals 2 pi over 5 over 2. Don't try to be a hero. Keep change flip, write it out. Don't try to be tough. Times 2 over 5. Period equals 4 pi over 5. That's the full period. So the quarter period is 1/4 of 4 pi over 5. Let's use our noggin. The 4 is just crossed out. What's 1/4 of 4 pi over 5? Well, it's just pi over 5. Now, how cute is this? Oh, it doesn't fit. How cute is this? Because pi over 5 already has a common denominator. How happy are we? So happy. Did I do that on purpose when I designed the question? I doubt it. So here, that is negative 6 pi over 5. I just can't fit it in the box, so I'm not trying to be a hero. Negative 6 pi over 5 is that point right over there. All of these markers are quite horrible. That's what I get for sharing my markers, and everyone presses too hard. Now the tip is gone. Now I'm going to add pi over 5 every step of the way. So if you're at a negative and you're adding pi over 5, that means our next location is negative 5 pi over 5. Could you reduce it, make it negative pi? You could, but who wants to do that? This video is longer than the last one. I can't believe this. Negative 4 pi over 5, negative 3 pi over 5, and last, negative 2 pi over 5. This is another reason I don't like to draw my x and y axes. So my y-axis is somewhere over here, and my x-axis is somewhere down here, but I don't even need it. It doesn't really matter. Domain and range are done. Oh, a thing I forgot to mention up above is cosine. What kind of symmetry? It is, if we keep going, if I fold it in half, it has that butterfly symmetry, kind of like the cosine graph. So that symmetry is even. So if I plug in a positive or a negative value, I get the same output. That is the parent function is even. Not every transformation of cosine is even, just like not every transformation of any graph consists with the same symmetry. Certain things can or won't change and the symmetry can stay. So usually those things are, you can change a vertical stretcher, compression, or reflection. That won't affect your symmetry. If you shift it up or down, an even graph will still be even, but an odd won't be odd. A horizontal stretch or compression won't matter, but if you shift it, nothing will maintain its symmetry unless, let's not get into the periodic nature of it. We'll save that conversation for another day. So thumbs up if you kind of get it. Hopefully you fast forwarded to the parts you needed. Thumbs down if you hate graphing cosine. I don't know what to tell you. I have tons of videos of me graphing cosine, graphing trig, full lessons, like heavy. Like the trig videos are A+. Okay, so go find those. I highly recommend. Next is going to be cosecant, which is the reciprocal of sine. I've already done a whole bunch. Find what you need. Leave a comment. Look in the description down below. Thumbs up, thumbs down. Bye.